Have you ever gazed up at the night sky and marveled at the planet's celestial dance around the sun? This mesmerizing ballet of cosmic bodies isn't just a random act of the universe. No, it's a meticulously choreographed performance, following a set of rules laid down by a man named Johannes Kepler in the 17th century. Kepler, a stargazer and philosopher, cracked the cosmic code that dictates the planet's orbital pirouettes. His 3 laws of planetary motion, which we'll delve into shortly, explain the elliptical paths of planets, their varying speeds, and the relationship between their orbital periods and distances from the Sun. These laws are the unseen threads that bind the cosmic fabric, enabling the celestial bodies to maintain their orbital harmony. So, stick around as we decode the cosmic rules that govern this graceful dance. We're about to embark on a journey through Kepler's cosmic choreography, unveiling the secrets of the planet's celestial ballet. First up on our cosmic dance card is the Elliptical Extravaganza. Now, when you think of an orbit, a perfect circle might come to mind. But hold on to your telescopes because Johannes Kepler, our 17th century starry-eyed maestro, had a different tune to play. Instead of perfect circles, Kepler proposed that planets follow an elliptical path around the sun. What's an ellipse, you ask? Picture an egg. Yes, the breakfast kind. An ellipse is sort of like a squished circle, or if you prefer, an egg-shaped dance floor. Now imagine the sun and a planet in this cosmic dance. You'd think the sun, being the heavyweight star of the show, would be smack in the middle of this dance floor, right? Well, not quite. Kepler's first law tells us that the sun is not in the center but at one of the 2 focal points of the ellipse. To put it simply, the sun doesn't take center stage but rather a corner spot on this egg-shaped dance floor. A bit unconventional, wouldn't you say? But that's the beauty of it. The sun and planets aren't doing a simple 2-step in a circle. They're waltzing in ellipses, adding a little flair to their cosmic dance. Kepler's first law, the law of ellipses, is an essential piece of the puzzle in understanding how our solar system works. It explains why planets don't move at a constant speed, but instead speed up as they get closer to the sun and slow down as they move away. So, the next time you look up at the night sky, remember the elliptical extravaganza. The planets aren't just circling the sun, they're performing an intricate dance in ellipses. So the sun takes the corner spot, and the planets follow an elliptical path around it. It's a cosmic choreography that's been going on for billions of years, and it's all thanks to the genius of Johannes Kepler. Next, we dive into the area adventures. This is where we understand Kepler's second law, an intriguing aspect of planetary motion that involves speed and area. Now this might sound a bit complex, but let's simplify it with a fun analogy. Picture a celestial hula hoop routine. Imagine a planet in its elliptical orbit around the sun. Now visualize a line connecting the planet and the sun. As the planet moves along its orbit, this line sweeps out a certain area, like a cosmic broom. This is where the hula hoop magic comes in, so stay with me. Think of the planet as a hula hoop dancer and the line connecting it to the sun as the hula hoop. As the dancer twirls, the hula hoop sweeps out an area. Now here's the fascinating part. Kepler's second law states that no matter how fast or slow the planet goes, this cosmic broom sweeps out the same area in the same amount of time. So when the planet is closer to the sun, it moves faster, like a hula hoop dancer spinning quickly. The line sweeps out a shorter but wider area. Conversely, when the planet is further away, it moves slower, like a dancer spinning leisurely. The line sweeps out a longer but narrower area. But guess what? These areas are the same. That's right. Whether the planet is close to the sun or far away, the area it sweeps out in a given time is constant. It's a beautifully timed celestial hula hoop routine, with each planet moving at its own beat, yet all in perfect harmony with Kepler's second law. This area adventure unveils the intimate dance between speed and distance in the cosmic ballet of planetary orbits. It's a fascinating insight into how planets pirouette around the sun, a testament to the meticulous choreography of the cosmos. Just like a hula hoop, no matter where the planet is in its orbit, it sweeps the same area in the same amount of time. Finally, let's groove to the rhythm of the time tunes. This is where Kepler's third law comes into play, showcasing a harmonious relationship between a planet's distance from the sun and its orbital period. Imagine a cosmic racetrack where the planets are the competitors. The track isn't a simple loop, but an elliptical orbit around the sun. In this cosmic race, each planet has its own lane, marked by its distance from the sun. The inner planets like Mercury and Venus have the inside lanes. The outer ones, like Jupiter and Saturn, are stuck on the outer lanes. Now, you'd expect that all planets would take the same time to complete a lap, right? But that's not the case. The planets closer to the sun on the shorter lanes zip around much faster. That's why Mercury, the closest to the sun, is also the speediest, completing an orbit in just 88 Earth days. On the other hand, the planets on the outer lanes have a much longer journey to make. They move at a more leisurely pace. For instance, Neptune, the outermost planet, takes a whopping 165 Earth years to complete one orbit. This isn't just a random pattern. Kepler discovered a precise mathematical relationship here. He found that the square of a planet's orbital period is proportional to the cube of its distance from the sun. This might sound like a mouthful, but it's essentially a cosmic rhythm, a time tune that every planet dances to. What's fascinating is that this law applies not just to our solar system but to any planetary system out there. It's a universal principle, a cosmic truth. Kepler's third law allows us to measure the scale of the universe, predict planetary positions, and even plan space missions. So next time you think about the planets, remember this cosmic race. Each planet, in its own lane, twirling at its own pace, all in sync with the universal rhythm. The closer the planet is to the sun, the faster it completes its orbit. This is the cosmic choreography at its finest, the grand dance of the planets, all orchestrated by the time tunes. You might be wondering, why does any of this matter? Well, let's get into it. Kepler's laws aren't just fascinating tidbits to impress your friends at parties. They're fundamental to our understanding of the universe, and the celestial ballet that unfolds above us every night. Firstly, Kepler's laws give us the keys to decipher the planetary motion. They let us understand why planets move the way they do, spinning in their orbits like dancers on a cosmic stage. Kepler's laws are the choreographer's notes for this interstellar performance, telling each planet when to speed up, when to slow down, and where to move next. But the magic of Kepler's laws extends beyond mere understanding. They also allow us to predict astronomical events like eclipses. By understanding the elliptical paths planets trace around the sun, we can foresee when they'll align for that awe-inspiring moment when the moon cloaks the sun, or when Earth's shadow creeps across the moon's face. It's like having a schedule for the universe's most spectacular shows. And let's not forget about space travel. Kepler's laws are invaluable for launching spacecraft to distant worlds. They provide the roadmap for navigating the cosmos, guiding us on when to blast off and how to steer to reach other planets. Without these laws, we'd be lost in the cosmic wilderness, unable to carry out missions like sending rovers to Mars or probes to the outer reaches of our solar system. In essence, these laws are the hidden formulas, the secret sauce, that keep planets spinning through the void. They are the blueprint that nature uses to choreograph the cosmic dance of celestial bodies. Without them, the universe as we know it wouldn't exist. So, the next time you look up at the night sky, remember the genius of Kepler and his laws. They are the silent conductors of the symphony of stars, planets, and galaxies that we call the universe. Kepler's laws are the hidden rules that keep planets spinning through the void. So, as you look up at the night sky and marvel at the celestial dance of the planets, remember the genius of Johannes Kepler and his 3 laws that govern this cosmic choreography. The planets are not merely spinning in space, they are performing an elliptical extravaganza, moving at speeds governed by area adventures and keeping time with the cosmic tunes of their orbital periods. This isn't just a beautiful spectacle, it's a precise and predictable pattern that has helped us understand our place in the cosmos, predict celestial events, and venture into the vastness of space. Kepler's laws are more than just scientific theories. They are the underlying rhythm of the universe, the cosmic code that keeps the celestial orchestra in harmony. Remember, they are not just random dots, they're dancers obeying the elegant laws of the universe. Maybe one day, we'll join them in this breathtaking cosmic waltz.